everyone. Today we're going to look at route matrices, also known as route matrices, depending where you're from. And we're only going to focus on one-step routes today. So route matrices show us the possible connections between different locations. So let's look at some examples here. So there are 4 towns, Aville, Bville, Cville, and Deville, and they're all connected by roads. Create a one-step route matrix to represent the below diagram. The first thing to realize is there are 4 towns in this situation, or 4 vertices on the network. So what that means is we're going to have a 4x4 matrix as a result. So we've got A, B, C, and D, which matches A, B, C, and D in the diagram. Now, on the left, we're always going to say this is from, and at the top, we're always going to say this is to. This will make a little more sense in a minute, but please remember we always follow this convention with from on the left and to at the top. Alright, so I filled in the first answers here. Let's try to understand what's going on. A one-step route matrix means you can only go down one road. So starting from A, it is not possible to get to A if you have to take one road. So look at the diagram here. If we start at A and you have to take either this road or this road, will you end up at A when you're done? Well, if I take that road there, no. If I take this road here, no. So it is not possible for me to go from A and finish at A in one step. Looking back at the diagram, if I wanted to go from A to B, there is only one possible way for me to do that. I can go from A to B along this line. No other line will get me there in one go. In a similar way, there's only one way for me to get from A to C. I'd go straight down this path. And no matter what I do, starting at A, I cannot get to D because it will require at least 2 roads to travel. Alright, so here's the next row. So starting at B, there is only one way for me to get to A, so I have to take this road here. Starting at B, it's not possible for me to get back to B because I have to step down at least one road. Starting from B, there's one way to C, which is down here, and starting at B, there's one way to D down here. So hopefully that makes sense of those numbers there. For the next one, pretty straightforward. C to A, there's one way of getting there. C to B, there's one way of getting there. C to C, I can't do. And finally, C to D is not possible because I'd need to go down more than one route. So that's why it's a 0 there. And finally, using D to A is not possible because I have to take 2 steps. D to B is all good. D to C, can't get there. I need 2 steps. And D to D is not possible. So don't overthink it. A route matrix is just showing possible connections from a place to a place, okay? And with a one-step route matrix, you have to take one step at least. So if you notice here, the diagonal, we call this the leading diagonal, is all zeros for this one-step route matrix because you have to step off the starting point, meaning you cannot finish at the same point. So that's why all those are 0 there. If you look at the diagram on the left, we've got something interesting here. We've got these arrows pointing one way, just like this. So this is going from A to B, but not backwards. And same here, this line goes from C to B, but not backwards. So one directional arrows act as one-way streets. So if you've ever driven in the city down a one-way street, the cars can only go one direction. It's the same idea here. You must follow the direction of the arrow. You cannot go against the flow. So let's start to look at this. So the first one here, A to A is still 0. That makes sense. A to B is 3 because starting at A, I could go through the top path, the middle path, or the bottom path here. Makes sense. A to C is 1 as usual, and A to D is not possible. We know that. For the next one here, B to A is 2. Now notice, this is different from here. A to B was 3, but B to A is 2 because we can go on the top, we can go on the bottom, but we cannot go against this flow, okay? This is a one-way street. So there's only 2 ways to get back to A starting from B. B to B is not possible. B to C we can't do because of this one-way arrow, okay? We can't go against that flow there. And B to D is still possible. All right, everything's pretty much the same here. C to A is good. C to B is good. Can't go C to C. Can't go C to D. And lastly, D is pretty much the same as well. D can not get to A, can get to B, can't get to C, can't get to itself. So nothing's too much different there. Alrighty, on this diagram we have some loops. Now if you notice, there's like a ring going around B here. That's interesting. And there's also one on C, and it's incorporating a one-directional arrow. So what do loops mean? Well, loops allow a vertex to connect to itself. An arrow on a loop indicates a one-way loop. So normally in all the past examples we looked at, you can't go from like A to A, B to B, because you have to step off it. But loops allow you to connect to yourself. Maybe this is like a roundabout or a specific like scenic route on a road that takes you all the way back to where you were. Who knows? If we start looking at this matrix here, we can see A to A is 0, A to B is 1, A to C is 1, and A to D is not possible. Nothing's changed there. But things get interesting with B. B can connect to A, we know that. B to B is 2. Why is B to B now 2? Well, I could go around the loop this way, starting at B, or I could go around this way. So there were 2 ways to get from B to B. Interesting. B to C is 1, so that's okay, and B to D is 1. Now if you look at C, C to A is still 1, C to B is still 1. Now C to C is only 1 now. Interesting. Why isn't it 2 like up above? Well, I've added this one directional arrow here. So this is like a one-way loop around here. So C can connect to C, but there's only one little loop you can do. And finally, C to D is not possible. And last but not least, D is pretty much the same as last time. Nothing's changed there. All right, everyone, I've got a question for you now. I've made this diagram on the left. It's got a bit of everything going on. It's got one-way street, it's got loops, it's got it all together. So, 4 landmarks in a city are connected by roads. The following diagram represents the connections between each landmark. I would love you to pause the video and try to make the matrix for this here. Please note, I chose letters and names that weren't like necessarily in alphabetical order, but I really suggest you put them in alphabetical order in your matrix. It makes it much easier to keep track of what's going on. So we've got ADFO, ADFO. Could you please try to work out the one-step route matrix for this problem here? Alrighty, let's try to go through this problem. First of all, A to A is 0 because there was no loops on A. A to D is 2 because there was one path from Anorlondo and another one there. A to F is 1 because this is just a one-way street going down to Firelink Shrine there. And A to O is also 1 because this is the only path we can take to Ulasil. Awesome. For the next one. So Duke Archives to Anorlondo is 2 because again, there's no arrows, so you can go down that path again. Duke's Archives to Duke's Archives is 2 because there's a loop. You could go around this way or go around this way. Duke's Archives to Firelink Shrine is not possible. There's no route there. And finally, there's only one path going from Duke's Archives to Ulasil, so straight down here. Alrighty, so starting at Firelink, there's no way to get back to A because we can't go against the flow. We cannot get to the Duke's Archives because there's no connection there. We cannot get to ourselves because there's no loop, but we can take 2 paths to Ulasil down below. And finally, starting at Ulasil, we can get straight to Anorlondo with a path there. We cannot get to the Duke Archives because we cannot go against the flow. We can get to Firelink, but only one way, okay? There's only one way to get across. And finally, we cannot get to ourselves because there is no loop. Thank you so much for watching. If you have any questions at all, please let me know in the comments below. Apart from that, hope you have an awesome day.